You ever wonder how Netflix just knows what movie you'll want to watch next? Or how a company can predict its sales months in advance? Well, a lot of the time, the magic behind that is something called regression analysis. Now, I know, it sounds super technical, but it's really just a smart way to use information we already have to make really good guesses about the future. So let's pull back the curtain and see how it works.
This is the big question, right? And honestly, it's something we all do in our heads every single day. You think, okay, if I study for one more hour, I'll probably get a better grade. Or if I save a little more money this month, I can get that thing I want sooner. Regression just gives us a powerful mathematical way to take those if-then thoughts and make them way more precise.
Okay, think about it like this. You're trying to figure out the perfect recipe. The things you can control and measure, like the amount of time you work or the level of education you have, those are your ingredients. We call those predictors. And the final result, the thing you're trying to achieve, like how much money you make, that's the outcome. It depends on the ingredients. Regression is all about figuring out the exact recipe that connects those ingredients to that final outcome.
So, at its core, regression analysis is like being a data detective. You're sifting through all the information you have, looking for clues, patterns, and connections. It's all about building a little mathematical model that tells the story of how different things are related to each other.
Okay, so what's the point of all this? What can we actually do with regression? Well, it really boils down to two main things: understanding what's happening right now and predicting what's going to happen next. First up, we can measure influence. You can ask questions like, how much does an extra hour of sleep actually affect my productivity the next day? Regression can give you a number for that. And second, of course, we can make predictions. If you're running a business, you could use it to figure out which customers are the most likely to buy your new product. It's incredibly useful. All right, let's roll up our sleeves and get into the most common, the most fundamental type of regression out there: linear regression. And just like the name says, it's all about finding the straight story in your data. It's simple, but you'll see just how powerful a straight line can be.
Now, linear regression comes in two main flavors. You've got simple linear regression, where you're using just one thing to predict an outcome. For example, using the number of hours you study to predict your exam score. But life's usually more complicated than that, right? That's where multiple linear regression comes in. We can add more ingredients to our recipe, like how much you slept or how many practice tests you took, to get a much richer, more accurate prediction.
So, where do we start? Well, the very first step before you do any fancy math is to just look at your data. And a scatter plot is perfect for this. You just throw your data points onto a graph, and if it looks like they're all kind of dancing along in a straight line, boom, that's your first big clue that linear regression is probably the right tool for the job.
Okay, so we see a trend. But how do we draw that one single perfect line through all those scattered dots? That's the real magic of linear regression. It uses a mathematical formula to find the one and only line of best fit, the line that gets as close as humanly possible to all the data points at once. Think of it like finding the perfect average, but for a line instead of just a set of numbers. So going back to multiple linear regression, think of it like going from a simple light switch to a full-on sound mixing board. With simple regression, you have one fader, one variable to adjust. But with multiple regression, you've got a whole console of faders. Each one represents a different predictor, and you can tweak all of them to create a much more nuanced and powerful prediction. So far, everything we've talked about has been for predicting numbers: a salary, a test score, a temperature. But what happens when the answer you're looking for isn't a number? What if it's a simple choice, a yes or a no, buy or don't buy? For that, we need a completely different tool. Let's talk about logistic regression. I mean, think about it. Your life is filled with these yes or no questions. Is this email spam or not? Will this customer renew their subscription? Will this team win the game? A straight line from linear regression just can't answer those kinds of questions. We need a different approach for these kinds of outcomes. And here's the key difference. Linear regression gives you a number, like a ruler giving you a precise measurement. Logistic regression, on the other hand, gives you a probability. It's more like a weather forecast. It doesn't tell you it will rain. It tells you there's an 80% chance of rain. It gives you a number between 0 and 1, representing the likelihood of a yes. So, to put it another way, with logistic regression, we're not trying to predict the exact level of happiness a customer will have.
We're just trying to predict whether they'll fall into the happy bucket or the unhappy bucket. It's all about classifying outcomes into one of two categories. All right, so you've crunched the numbers, you've built your regression model. Congratulations. But hold on. Before you go and bet the farm on its predictions, you have to ask a really important question. Is this model actually any good? You got to taste test your recipe before you serve it to everyone, right? You need to make sure it works. One of the first things you'll check is a value called R-squared. The easiest way to think about it is like a report card for your model. It's a score that tells you what percentage of the story your predictors are actually explaining. Now, a good score really depends on what you're studying. In physics, you might expect a 99%. But in a complex field like predicting human behavior, an R-squared of 30% can be fantastic.
But a high R-squared isn't the whole story. Your model has to play by some important rules to be trustworthy. For one, the relationship you're modeling needs to actually be a line. You can't just force a straight line onto a curvy pattern and expect it to work. And another big one is something called multicollinearity. It's a mouthful, but it just means your predictors shouldn't be telling you the exact same thing. It's like having two weather apps that are always identical. The second one adds no new information and just muddies the waters. So there you have it, a quick tour of the world of regression. From straight lines to simple choices, it's an amazing tool for finding patterns and making sense of the world. And the best part is, now that you know the basics, you can start seeing these potential relationships everywhere. So I'll leave you with this. What's a pattern in your life you're curious about? What connection would you want to explore next? You might just be surprised at what you can predict.